In this training video, we will learn how to add wall framing, panelize the walls, add wall panel macros such as panel breaks, generate parts, and create wall panel drawings. Before we begin drawing the wall framing, let's review a few settings we covered in the first two training videos, set up in walls. Set up Vertex to frame the full length of the walls, or panelize the wall framing for specific lengths. In this project, the main floor walls will be framed to full length. We will set up the second level walls to be panelized. Let's begin on the first level wall layout. Switch the layout to the first level wall layout, go to Drawing Model Pairs, and select First Level Wall Layout. When we created this project in the first training video, Intro and Setup, we covered a few settings that contribute to the wall framing. Under Project Document Browser, expand Settings, Location and Height, and select 3D Levels. 3D levels control the wall heights and floor depths for each level. For the first and second floors, we assigned a 12-inch deep floor system. Zoom in on the first and second levels in the cross-section. We have assigned a height of 9 foot 1 1/8 for the first level, and a height of 8 foot 1 1/8 for the second level. Unless we modified the wall heights for an individual wall, all the walls will be assigned these heights. Select Cancel to close the window. Project parameters control the wall framing parameters for each level. Project parameters are under the Project Document Browser, under Settings, Design Setting, Project Parameters. Here you can set up the wall framing to frame the entire length of the wall as one wall segment, or set up Vertex to panelize the walls to preferred lengths. For each wall framing set, you can assign the panel break max length, minimum length, and preferred lengths. When adjusting the length also needs to be changed for each wall type. Below are tabs for exterior bearing walls, exterior non-bearing walls, gables, interior bearing walls, and interior non-bearing walls. For the first floor wall framing, we will frame the walls full length without any panel breaks. Set the max length and preferred lengths to a large number. Let's assign 800 inches to both fields. Remember to change the fields for each of the wall types for the first level wall framing. For the second level wall framing, we will panelize the walls using the default max length and preferred length settings. All the second level wall types are assigned the default settings. The default window rough opening height can be assigned under the level wall set. For each level, the default is set to 82 inches. We will leave it as the default for all the wall levels. Select OK to close the window. In the second training video titled Walls, we covered wall frame tools. The wall frame tools are rules assigned to a wall that instruct Vertex to which framing materials to assign to a wall framing details, on-center stud spacing, framing around openings, and various other wall framing settings. Wall frame tools is part of the wall framing layer within a wall type. To view wall framing tools for a wall type, go to the Modeling tab, Wall Layout, and select Walls. In the exterior wall library, select the 2x6 exterior bearing with horizontal siding. Under the Layers panel, select Frame Framing Type, 2x6 framing. Right mouse click, select Framing Tools. Under the Framing Tool window, the type of tool is displayed, along with the tool library and the framing tool. The exterior 2x6 bearing framing tool has been assigned to this wall. Click on the drop-down field to see the other framing tools in the library that can be assigned to the wall type. For example, you can assign a tool that has a DUG for number 1 material grade. Under the General tab, there are settings for a panel label, framing details for the corner, T-intersection, and wall ends. To change a detail, click on the Select button to open the available details. Click on the green diamond to select the preferred detail. Select the upper right X to close the window. Switch to the Studs tab. In this section, you can set the stud material for the common studs and studs at sheet seams, set the stud quantity and spacing, as well as the stud start from location. Under the Plates and Block tab, you can select the top and bottom plate materials, set the plate quantity, and change the detail. Click on the Select button next to the detail name. In the Detail window, select the detail by clicking on the diamond next to the detail. I'll select X to cancel and close the window. You can also set the horizontal and end blocking, as well as set the blocking height and type. Under Openings, here you can set the sill and cripple material, set the header detail, and the jack and kings for each of the 3 header openings. You can also adjust the max length for headers 1 and 2. Under Anchors and Service Holes, for anchors you can set the type of anchor, the offset from the end, as well as the spacing. Add service hole height and diameter information if you are exporting data to an automated saw. We'll leave our framing tool settings as is. Select the Cancel button. And select Cancel to close the library window. Framing tools can be modified for a specific wall. Double-click on the family room back wall. Select the framing layer 2x6 framing. Right mouse click and select Framing Tools from the menu. You can change the framing tools for this specific wall. For example, if this wall required studs to be spaced at 12 inches on center, you can change that under the framing tools. We will leave the framing tool settings as is. Select Cancel, and select Cancel again to close the wall library window. Now that we have our wall framing settings assigned, we can proceed with panelizing our first level walls. The wall panel tools are located under the Modeling tab, Panel, Wall tool. We will cover the basic wall panel tools, like the Panel Break macro, the Generate Panels and Generate Parts programs. We will also add some additional macros found under the Wall Panel Layout Accessories library. Macros are small programs or tools that tell the software to add additional framing components at a specific location. We will also add special framing around an opening. Special framing is a framing detail that overrides the framing tools that have been set in the wall type. Before building the wall panels, the framing macros must be added first. Let's start by adding a Panel Break macro. The Panel Break macro can be found under the Wall Panel menu and under the Wall Panel Layout Accessories library, under Building Components, Wall Panels. Double-click on the Panel Break macro. The status bar at the lower left corner is prompting us to select a wall to assign the panel break to. Next, select the front wall. We will add a panel break 18 feet from the lower left exterior wall corner. With the mouse cursor on the corner, set the Q key to use it as a reference point. Now move the mouse over to the right and type in 18 feet in the distance field. Zoom in next to the exterior door to see the panel break symbol. Next, let's add some double studs in the exterior wall that are in line with the 2 stairwell walls. Go to the Wall menu under the Modeling tab and select Wall Panel Layout Accessories. Find the Exterior Studs to Floor Plan macro and double-click to select it. Next, select the exterior front wall. In the Extra Stud Properties window, confirm the studs match the wall width. Set the quantity to 2 for double studs. If you need to change the stud profile, click on the SEL button for Select. Next, select the library and Profile. I'll select Cancel to leave the settings as is. Select Center in the side field. We want the double studs centered in line with the stairwell walls. Leave Rotate Studs 90 degrees unchecked. There are also material presets to automatically set the size of the studs. Select the OK button. Next, select the exterior wall again. To set the location, select the center line of the stairwell wall. Select the other stairwell wall to add the other double stud macro. Select the Escape key or right mouse click and select Exit to close the command. Now we have 2 double stud macros in line with the stairwell walls. Let's add one more macro. Let's add a beam pocket to floor plan macro. At the family room, we have a drop beam spanning from the kitchen corner over to the right exterior wall. Let's add a beam pocket macro to support the right beam end with additional studs. Since the beam rests over a window, for training purposes, we will move the window over so it is in line with the sliding glass door. To move the window, select the window, then click on the middle grip point of the window. As we move the window, you'll notice that it is locked to the wall. Let's move the window so it is centered with the sliding glass door. Click on the middle of the sliding glass door to line up the window. Notice how the window dimensions adjusted when we move the window. Select the Escape key to unselect the window. Under the Modeling tab and Panel section, select Wall. In the menu, go to the Wall Panel Layout Accessories. Find the Beam Pockets to Floor Plan macro, and double-click it to activate it. In the Beam Pocket Properties, we have material presets to automatically change the size of the jack and king profiles. Select 2x6 to match our exterior wall framing. The jack and king sections are now updated to 2x6 framing. For jacks, set the quantity to 2 jacks and leave the quantity to 1 for kings. You can set which side of the beam pocket to add the kings. Right, both, left. Set the side to both sides for kings. We need to set the pocket width wide enough to allow for the beam to fit in the pocket. We will also need to know what height to set the jacks to. Let's cancel to close the window. We need to obtain the beam width and the height of the bottom of the beam so we can specify the correct height for the jacks. Select the F2 key to switch to the 3D view to get the beam measurements. Switch to the framing model view. Zoom in on the second floor drop beam. Select the Verify Distance tool from the toolbar. To get the beam width measurements, select the bottom corner of the beam, and then select the beam corner at the opposite side. On the left side, you'll see the Verify Distance panel. We have a distance of 5¼ inches wide for the beam. Zoom out a little so we can see the corner of the floor framing. To get the distance of the bottom of the beam from the top of the floor sheathing, click on the sheathing corner and then select the bottom corner of the beam. Select Cancel to close the Verify Distance panel. Go back to the toolbar and select Verify Distance again. Next, select the bottom corner of the beam and then select the corner of the floor sheathing. If there's enough space, the distances will be displayed on the screen. As you can see, we have a distance of 8 foot 5 inches or 101 inches from the sheathing to the bottom of the beam. Select the Cancel button in the Verify Distance panel or hit the Escape key to end the command. Switch the model back to the architectural view and press F2 key to go back to the 2D view. Let's go back to the Wall Panel Layout Accessories menu and select Beam Pocket to Floor Plan macro. In the Beam Pocket Properties, select 2x6 material preset, set the quantity to 2 for jacks and the quantity of 1 for kings. For sides, set to both to place kings on each side of the beam pocket. For the pocket width, we'll set it to 5½ inches wide to allow for a 5¼ inch beam to fit in the pocket. For height of jacks, we need to set that value to 101 inches. This is equivalent to the 8 foot 5 inch measurement from the floor sheathing to the bottom of the beam. Clip sheathing removes the wall sheathing at the beam pocket. You can remove the wall sheathing from the interior side, the exterior side, and both sides of the wall sheathing at the pocket. Let's set it to interior. We only need to remove the wall sheathing at the interior side of the beam pocket. Select OK to accept the selections. Next, click on the right exterior wall. With the beam pocket macro linked to the wall, we need to set the location of the beam pocket. Select the wall center line of the exterior wall at the kitchen. This will line up the beam pocket with the center of the wall. To exit the command, select the Escape key or right-click and select Exit. As you can see, we have a beam pocket in the wall, which is in line with the kitchen exterior wall, which is also in line with the drop beam. We went over just a few examples of the wall panel macros available in Vertex BD, but if you browse the library, you can see that there are numerous other macros available. Let's go over special framing. Special framing for openings allows the user to create a framing detail for openings that require different framing than what was set up as a default under the wall framing tools. In this project, we will create special framing and apply it to the sliding glass door. The special framing tool is found in the wall menu under the Modeling tab panel section. In the opening special framing utility window, there are tools for editing the special framing details, such as add a new special framing detail, edit an existing special framing detail, or deleting a special framing detail. To create a new detail, select Add New Special Framing Detail. The status line in the lower left corner is prompting us to select a wall. Select the wall of the sliding glass door to obtain the wall framing properties. The opening framing parameters window has several buttons for saving a preset, loading a preset, editing an existing preset, and a label button for editing additional label text to apply to the label. If you load a preset, the name of the preset will be displayed in the Loaded Preset field. In the Label field, you can assign the label to your preset. The label will be displayed in the drawing. Similar to the opening settings in the wall framing tools, you can select a header type detail. You can also assign the material for the header, sill, and cripple. You can also assign material for the left and right side jack and kings, along with the quantity. There are also material presets to automatically assign a size to the sill, cripple, jack, and kings. Let's change the header type detail. Select the SEL button next to the header type. In the header selection window, go to the drop headers and select the triple drop 3 header. Click on the diamond next to the detail to select it. Let's change the header material to 2x12s. Select the SEL button next to header. Select the code drop-down field and select 2x12 header. Select OK to close the window. Let's go ahead and change the quantity of the kings to 2 for both the left and right side. Select OK to close the window. Next, zoom in on the sliding glass door and select it to assign the special framing detail to the opening. Let's move the label to the inside. Move the cursor over to the center of the label to find the grip point. Select the grip point and move the label over to the right side of the sliding glass door. You can see the label is made up of asterisks. That's because we didn't change the label default field. The additional header, jacks, and king info are also part of the label. This information can be turned on or off, or changed to different information. This is done under the Label button. Now that we've added wall panel macros and special framing around an opening, we can move on to generating the wall panels. There are several ways to access the Generate Panel tool. One is to select a specific wall, then right mouse click and select Generate Panels from the context menu. You can also select Generate Panels from the ribbon. Select multiple walls by clicking on a wall. Keep your finger on the Control key and select another wall to panelize multiple walls. With the wall selected, access Generate Panels from the Wall tab panel menu. I'll select Escape to unselect the walls. And another way to access the Generate Panels tool is to go to the Modeling tab, Panel section, and select Wall. Select Generate Panel from the menu. In the Wall Panelizing Settings window, you can adjust settings on how to panelize the walls. You can make adjustments to the settings and save the project-specific settings or reload default settings. We will cover just the basic settings. Under Structural Layers, you can set the layers to include or exclude when panelizing a wall. Under Corner Details, set how you want the corner details handled. Options include vertical walls extend, horizontal walls extend, clockwise orientation, or counterclockwise orientation. We'll skip the wall panel settings. Those usually do not require any adjusting. Under Set Panel Label Using, Wall Attributes uses the label set in the Wall Framing tool. Wall Type can be used to override the label set in the Wall Frame tool. Use the panel label section to apply a panel label ID and number. Currently, it is set up for an E prefix for exterior and an I prefix for interior panels. Both will begin with a panel number of 1. The first panels will have a panel ID label of E1 for exterior and I1 for interior. I'll set the panel label back to wall attributes and use the labeling system assigned in the wall frame tool. You can set the panel to have an interior view, and you can leave out layers which do not have any framing tools, such as siding and drywall. There are additional panel settings under the Advanced, Batten Settings, Corner Details, and Attach tabs. We will leave these settings as is. Select OK to apply our settings. Next, we need to select the walls to panelize. You can select Ctrl-A to select all the walls, or you can drag a crossing window around all the walls. By clicking on the upper right corner, keep the left mouse pressed, and drag a window down to the lower left corner to select all the walls within the window. Right mouse click to select OK, or V key to confirm. Vertex will panelize the walls and assign a wall panel label to each wall. Zoom in on the exterior wall panel label at the kitchen. The wall panel label ID for this wall is 1E2. 1 represents the first floor level, E indicates it is an exterior wall, and 2 is the number assigned to the wall panel. The asterisk indicates a wall panel drawing has not been created for this wall panel, or the panel framing has changed, and the wall panel framing is no longer in sync with the wall panel drawing. To remove the asterisk, generate a panel drawing for the wall. Select the Shift-A key to zoom out. Now that we have generated our wall panels, the next step is to create the wall framing by using the Generate Parts tool. To generate parts for a specific wall, select the wall panel label, right mouse click, and select Generate Parts from the context menu. The Generate Parts tool can also be accessed from the Modeling tab, Panel section, Wall menu. You can individually select panel labels. You can also press the Ctrl-A to select all the panel labels, or you can filter select the panel labels. Let's only select the exterior walls for now. Select any exterior wall label, and then press Ctrl-A to select all the other exterior wall panels. As you can see, only the exterior wall panels have been selected. Right mouse click and select OK, or press V to confirm to generate parts. Vertex then goes through the process of generating the parts for the exterior wall panels. Now let's generate the parts for the interior walls. Note that we are still in the Generate Parts tool. Select any interior wall panel label. Now select Ctrl-A to filter select the other interior wall panels. Select V to confirm, or right mouse click and select OK. Zoom in on the interior wall panel label near the stairs. This wall panel has been assigned the wall panel ID 1I9. 1 for first floor, I for interior, and 9 is the number assigned to the wall panel. We now have wall framing as part of the interior wall. Zoom in on the back corner of the family room. You can see we have framing at the exterior walls and framing around the openings. Select Shift-A to zoom extents. Now that we have the main floor wall framing completed, let's switch to the framing model. Select the F2 key, or select the switch between 2D and 3D icon to view the model in 3D. Select the house icon to change the model from architectural to the framing model. The framing model displays the first level wall framing and first and second floor framing. Let's hide the second level floor framing so that we have a clear view of the wall framing below. Select the Model tab at the lower left corner to switch to the Model Tree panel. To hide the second level floor framing, select the second level floor branch and right-click to bring up the menu. Select Hide to hide the second level floor framing. The 3D framing model shows all the parts that make up a framed wall, such as headers, jacks, kings, and other parts of the wall. Zoom in on the beam pocket framing. We set the macro to only remove the interior side of the sheathing at the beam pocket. To view the beam pocket framing, select the exterior sheathing at the beam pocket, and then press the H key to hide the sheathing. The jacks and kings were assigned in the beam pocket macro. Next, let's view the double studs we added to the right of the front door. We used the extra studs to floor plan macro to add the double studs in line with the stairwell walls. To view the double studs, select the 4 pieces of sheathing to the right of the front door, and select the H key to hide each piece. We place these studs to be in line with the interior stairwell walls. And just to the left of the door is a wall break. We added the wall break using the panel break macro. Editing wall framing in Vertex is easy. You can edit within the framing model, or you can isolate a wall to focus only on a single wall without the distraction of the rest of the framing. To edit the framing in a wall, zoom in on a wall and select a framing member. In this example, I'll select a stud and cut it into 2 pieces. Right mouse click and select the Cut tool. To move a profile, click on the midpoint grip and move in the desired direction. Use the U and I keys to constrain it along an axis. To access additional editing tools, move the cursor over an endpoint and right mouse click. In the menu, there are various tools for editing a profile, such as Move a Profile End, Trim to Plane, and Cut with a Plane. I'll use the Trim to Plane to extend the profile to the sill plane. You can also change a member to a different profile. Double-click on a member to access the Properties window. Check the cross-section checkbox to enable access to the code field, and select 4x6 stud as the new cross-section size. Manually extend a profile by clicking on an end grip. When moving an endpoint, the constraint is automatically locked. I'll bring the end of the profile in line with the adjacent studs. When in the 2D plan view, you can select a wall panel and isolate it for editing. I'll select the exterior wall panel along the kitchen. Right mouse click and select Edit Parts from the menu. A new window with only the selected wall panel opens. Rotate the wall panel to access the framing. You have access to the same editing tools as previously shown. In this example, I'll make a few copies of an existing stud. To close the window, select the red X in the upper right corner. Switch back to the 2D view and confirm you're in the architectural model. After completing all the wall framing edits, the next step is to create the panel drawings. Create the panel drawings for individual walls or for all the walls in one step. It's important to note if panel drawings already exist and you select Create Panel Drawings, a window prompting the user to either replace or update the existing panels will appear. Replacing the panel drawings will delete the existing panel drawings and prompt the user to select a new wall panel template. Updating the panel drawing will keep the existing drawings, but update the material schedules and the existing drawing and elevations on the panel drawing. Let's create a panel drawing for an individual wall. Select the wall panel label, right mouse click, and select Create Panel Drawing. Next, select a wall panel template from the panel drawing libraries. I'll select the wall panel A 11x17 template from the wall library. Select OK to create the drawing. Vertex builds the wall panel drawing. It adds the elevations and cross sections, and adds any material schedules that are part of the panel template. The wall panel elevation shows the sheathing outline and sheet label. It also shows the label for each individual framing member. Wall dimensions in a cross-section view are also shown on the drawing. The material list, found in the lower left corner of the panel drawing, includes the labels for each of the framing member. For example, BP stands for bottom plate, DTP is the binder, and S stands for studs. The quantity, material, description of the piece, and the length of the piece is also included in the piece list. The sheet schedule is found in the lower right corner of the panel drawing. The sheet label, quantity, material, and a description which shows the dimension of the sheet is included in the sheet schedule. The sheet title block displays the wall panel ID, the project name, the quantity. It also displays the panel height, frame weight, panel weight, and company information. To close the panel drawing, select the X in the upper right corner of the window. Another way to create panel drawings is to go to the Output tab and select Panel Drawings. An Element Drawings panel will open on the left side of the UI. The panel lists all the floor and wall panels in the project. The panel label, drawing status, floor level, and type of numbering is displayed. The panel drawing will display OK if the panel is up to date, or it may display out of date if the panel is not in sync with the model. To create multiple wall panel drawings from the Elements Drawing panel, select a panel, keep your finger on the Shift key, and select another panel in the group. Right mouse click and select Create. Next, select a panel template from the Panel Drawing Wall library. Vertex then creates the wall panel drawings for each of the selected wall panels. The drawing status updates to OK for these drawing panels, indicating that the drawings have been created for the walls and they are currently up to date with the model or project. You can open a panel drawing from the Elements Drawings panel. Select a panel, right mouse click and select Open. You will need to select Exit in the Elements Drawings panel to be able to select the panel drawing window. You can also open a single panel drawing by selecting the panel drawing label, right mouse click and select Open Panel Drawing. We completed panelizing all our first level walls. Now if you recall, in our project parameter settings, our first level walls were set to frame full length. Next we'll panelize the walls for the second floor level. Under project parameters, for the second level walls, we set our preferred lengths to 16 feet, 12 feet, 8 feet, and 4 feet. Those will be our typical wall panel lengths for our upper level walls. Let's switch to the second level wall layout. Go to the Drawing Model Pairs icon and select Second Level Wall Layout. Since we have already set the preferred wall panel lengths in the project parameters, manually adding panel breaks is not necessary. Panel breaks will occur automatically using our preferred lengths. Let's generate the wall panels. Under the Modeling tab, select Wall, and Generate Panels in the menu. Under the Wall Panelizing Settings window, we will leave all the settings as is. Select OK. Next, let's select all the walls to panelize. Click on the upper right corner, keep your finger on the right mouse button, and drag a selection window down to the lower left corner. Ensure that all of the walls are inside the selection window. Now right mouse click and select OK, or press the V key to confirm the selection. We now have all the wall panels for the second level walls. The next step is to generate the parts for the wall panels. Go up to the Modeling tab, select Wall, and Generate Parts from the menu. Again, we will drag a selection window around all the wall panels. Right mouse click and select OK, or press the V key to confirm the selection. Vertex then goes through the process of generating the wall framing for all the wall panels. To view all the wall panels, go to the Output tab and select Panel Drawings. You'll find all the second floor level wall panels have been added to the Elements Drawings panel. Let's create the drawings for only the second level walls. Select the column header titled Floor to organize the list by floor level. It makes it easier to select only the second level walls. Select the second level wall on the top of the list. Next, press the Shift key and select the last second level wall in the list to group select all the second level walls. Now right mouse click and select Create. Select the wall panel A 11 by 17 wall panel template drawing under the Walls library. Vertex then generates all the wall panel drawings. Select Exit to close the Elements Drawings panel. To open a panel drawing, select a wall panel label, right mouse click and select Open Panel Drawing. I selected the wall panel from a 30-foot long wall. As you can see, this wall panel was set to our maximum wall panel length of 16 feet. Select the X in the upper right corner to close the panel drawing. Let's view the wall framing in 3D. Select the F2 key to switch to the 3D view. And switch from the architectural model to the framing model by clicking on the house icon. Rotate the model to see all of the framing components. To rotate in 3D, press down on the middle mouse button and move the mouse while the button is pressed. Use the mouse wheel to zoom in and out. Select the F2 key to go back to the 2D view. And switch back to the architectural model by clicking on the house icon. Now that we have the wall panels for the first and second level walls, let's switch back to the first level wall layout and export to a PDF booklet. After all the panel drawings have been created, you can export them to a PDF set. Go to the File tab, select Export, and select Print PDF Sets. In the Select Set and PDF Type window, scroll down and select Panelized Wall Set. Select OK. Enter a file name or select OK to accept the default name. Vertex finds all the panel drawings in the project and adds each drawing to the PDF set. Once it's done, your default PDF viewer opens the PDF set for viewing. Vertex compiles all the wall panel drawings in the project into a single PDF. This concludes the wall framing tutorial for the wood version of Vertex BD.